Hi, welcome back. In this video, we are going to be looking at graphing square root functions. Before we get into actually graphing square root functions, I want to talk about the quadratic function and its inverse. So if I look at the function f of x is equal to x squared, I have the graph of this function here. So it's at 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, and negative 3, 9. If I want to find the inverse of this function, so that gives me y is equal to x squared. X is equal to y squared. Let's take the square root of both sides, and I get y is equal to plus or minus the square root of x. So I'm going to go ahead and graph this function here, or I'm sorry, this relation here, just to kind of see what it looks like. So really what I'm going to be doing here is taking each of the ordered pairs from this function and finding its inverse. So 0, 0 is pretty easy, and so is 1, 1. This is the point 2, 4, so it's going to become 4, 2. 1, 2, 3, 4, 1, 2. This is the point 3, 9. It's going to become 9, 3. It's about there. So I can now graph this. Then I want to find the inverse of this. So this was negative 1, 1. This is going to become 1, negative 1. This is negative 2, 4. So this is going to become 4, negative 2. And this is negative 3, 9. So this is going to become 9, negative 3. So this looks like this. So if I'm looking at this function or this equation here, this does not pass the vertical line test. So this here is not a function. When we're looking at the inverse function of y equals x squared, we're interested in the inverse function. So we want to figure out how we can make this into a function. And what we do is we say we are only going to take the top half. So we say that f inverse of x is just the positive square root of x. So we say we're not going to consider this negative. We are only looking at the positive. So when we are talking about y equals the square root of x, we are talking about the top half of the inverse relation of y equals x squared. So now that we have an idea of what it is we're talking about, let's look at our parent function. So we've got some really big, important things here. One really key defining piece of this is that I cannot put a negative number inside the square root. When I'm looking at graphing functions, I'm looking at real numbers. The square root of a negative number is an imaginary number. This is not real, and we are only interested in dealing with real numbers. Therefore, whatever is underneath the square root must be greater than or equal to 0. This is what gives us a domain restriction. So whatever is underneath the square root must be greater than or equal to 0. That tells me that my domain here is from 0 to positive infinity. Now x can be 0 because we can take the square root of 0. It's just 0. So this is giving me kind of my end point at 0. So if I plug 0 in here, I get the square root of 0, which is 0. This is my vertex. My vertex is at the point 0, 0. This relates to the vertex of my quadratic function here. It's this point here. So that is my starting point, and it is the most important point of my entire square root function. So now I kind of need to think about like what else is happening here. So I am going to go through and pick out a few more points. A key thing to keep in mind when you are picking out points is be really kind to yourself. So yes, I can plug in 1. The square root of 1 is 1. That was a really nice point. So I end up with the point 1, 1. I'm not going to plug in 2 because the square root of 2 is a really weird number. I don't know what it is. It's not going to be easy for me to graph, or I don't know what it is off the top of my head, but I do know what the square root of 4 is. The square root of 4 is 2, so I'm going to graph the point 4, 2. 1, 2, 3, 4, 1, 2. I could do more points, but 3 points is going to be enough. So my parent function looks like that. So it kind of starts going up, straight up, and it curves around to the right. So now let's look at the range of this function. What values of y are graphed here, or what values of y are possible? Well, my minimum value of y is 0, and y does equal 0, or y is a positive number all the way up to positive infinity. So my domain and range are both from 0 to positive infinity. When I'm looking at intercepts, for the x-intercept, this is when y equals 0, and for the y-intercept, this is when x equals 0. In this case, its x-intercept is also its y-intercept, is also its vertex, so it's kind of an uninteresting point. But then let's talk end behavior. So as x approaches positive infinity, y also approaches positive infinity. On the other end, x does not approach negative infinity. So we're going to talk about x approaching this end. And so this is x approaching 0, but it isn't just approaching 0 because it's only approaching 0 from the right. So to signify that, we are going to put a plus sign in the top right corner. That means as x approaches 0 from the positive side. So only coming from the right. So from the right, headed to 0, what's happening? Well, what happens is that y approaches 0. So this is my parent function. In the next video, we are going to look at what happens when we transform this parent function.